Hello students. Today we are going to discuss about analysis and security of DES and AES algorithms. See, after understanding the structure and what are the rounds, key size and everything about the standard algorithms of data and advanced, we are about to know in this session about the analysis part and also how secure these algorithms are. So if you can see the outline, so what are the effects we have, what are the analysis of DS and security purpose, and why we are going for the DS replacement. So what is the replacement we have is the AES. Now, what is the evaluation criteria it has and what is the security it is providing to us. Now, let us know about the DES avalanche and completeness effect. See, first is the avalanche effect, where this effect says that the change of one bit in the input or the key bit will be resulting in a vast difference in the output bits. So this is nothing but a disadvantage where the total plain text will be something else unless and until if we can understand something has happened in the input text. So this is nothing but the change in one input bit or it's in the key or in the plain text will be resulting in a vast change in the output bits. So if we can see, give an example here. See, can you see this? Plain text is 0000. So everything I have given the plain text as this, and key which I have utilized is this in the DES. Now, after having the plain text and key, I have applied all the rounds format, 16 rounds encryption process, so that I got this ciphertext. Okay. So now in the process of plain text, this bit has been updated to 1 here. See, can you see the second bit format? 1. So remaining plain text is same, but the last bit I have changed. The key is same, the content is same, only 1 bit has been updated. See the ciphertext change. So it's totally different, uniquely given, right? So the change in 1 bit will be deciding with the change in the output bits. So this is nothing but the avalanche effect, all right? And this DES will be giving the strong avalanche. So this is what the main analysis we have done. Next one is about the completeness. So completeness is with respect to the diffusion and the confusion. So are we giving the total diffusion and confusion properly? So diffusion is nothing but the plain text and the ciphertext combination should not be there, and confusion is nothing but the key and the ciphertext combination should not be revealed to the user at all. So are we with these two things? Means 75% we can say yes, but to crack with this, we have several n number of things for DES to understand with the weakness, right? So there are two weaknesses of DES. The first one is the cipher design, second one is the cipher key. Cipher design is, see, up to the, when we are discussing about the developer's point of view, it is not clear because designers will be thinking that why this extra rounds, like rounds are proper, why this initial and final permutations are needed, not required. So these kind of things like cipher design is having two defaults. Why there is a need of initial permutation and final permutation? This is taking extra time, but no security benefits given. So this is the one point to be noted under weakness analysis. Second one is the cipher key size. See, coming to the key size, it is only 56 bits, which is very easy to the hackers or attackers or the adversary, which we call. They will apply 2 to the power of 56 combinations to get our plain text back using several technologies. So this is the another weakness which we have analyzed for DES. And coming to the strength of this, we have only one strength. Again, the strength and the weakness are the key size. So 2 power 56 bits itself, rather than competing with our traditional things, DS is a super thing, right? So as we are going with the product cipher. Next, brute force will be looking very hard because 2 power 56 will be making 7.2. See, we can say 7.2 into 10 power 16 values. So research advances will be showing all the possibilities because there are a number of technologies to update with this, but the strength of DES is the same thing and the weakness is also the same thing which we are giving, right? See, as of now, after having several surveys, in 1997, one hack happened, but nothing happened to our data. 1998, cracker tried, but it took a few days, but he got with a vast cost also. In 1999, above combined in 2022 hours. So both combined together. So clusters of all the possibilities of brute force attacks and giving the cost and everything, they have cracked this DES, right? So this is not a big flaw of DES algorithm, but maybe the content, right? So this is what we are discussing about the DES strength. Next two strengths we have on the time of analytical attacks and also the timing attacks, right? So timing attacks, yeah. So when we are discussing about this analytical attacks which we have, this analytical attacks will be dependent again on the attacks which we have performed. So there are n number of attacks which are possible, that is differential, linear, and related key attacks. See, coming to the first point, differential attacks will be n number of attacks which are performing on the statistical analysis of your plain text, ciphertext, and all the known combinations. Linear cryptanalysis is a series of attack combinations which we do. So first they will try to understand plain text series, then the key analysis, then the ciphertext analysis. So this is one step-by-step analysis of the things. Next, related key attacks. So key attacks will be obviously, they try to understand how they can get the key from so and so authorized authorized entities. So you will be having key distribution centers and all those who are providing keys to us. So all this will be the strength of DES. Okay, so here the DES will be very strong enough to maintain all these sub keys, combinations, and everything. So coming to the timing attacks, these are dependent on the calculations part of the things, where time is dependent on the value of inputs, right? So if the plain text is very vast and if the DES is taking only 56 bits of key, so it may be deriving all its subkey combinations to understand the knowledge of consequences, right? So this is nothing but strength of DES dependent on timing, means where the vary of inputs will be varying in the timing attack. Means if the input is very small, the timing attack will be very less enough. Like it may be cracked 20 hours, within 20 hours only. If it is keep on extending, so your time also will be extending to 2 days, 5 days, like that. Okay, so this kind of attacks are very, very problematic. Timing attacks are very problematic in the swapping systems nowadays, smart cards and everything. So when we swap that, so immediately they will try to attack dependent on the secure system, in which secure system we are logged in, right? So these are some of the strengths of DES where it is strong enough to perform all the things. So why we need DES replacement is because of brute force attacks. Only the thing is brute force attacks to power 56 combination. So thus we have moved to triple DES where we have 168-bit key, right? So, but the drawback in triple DES is it is very complex and coding will be very hard. Okay. So, and it may not be suitable for the bigger block size. It will be suitable for the smaller content of smaller blocked elements. So thus AES entered. Now AES is very strong in the 128 to 192 to 256 key size, right? And stronger than triple DES, and its active life is 20 to 30 years. So as of now, its design is too good. Okay, in the design of DES, we have initial permutation, final permutation is not so necessary. So like that in AES, there is no such kind of operations which is not necessary. All the operations are mandatory. So coming to the evaluation criteria, it is secure enough, cost-wise also efficient, memory-wise also efficient, and its characteristics which are very suitable thing, flexible and simpler. So thus the strength of AES is nothing but it's a simplicity, key size, and very resistant to the all the attacks, known attacks. And coming to the speed and code point of view also, it is very strong enough. Okay, so these are all the criteria in which AES is very strong, proven that AES is very strong And thus there are very less brute force attacks and very less statistical and no differential and linear attacks till date. So this is the history of all the analysis and security point of view, criteria point of view, strongness, weakness point of view of DES and AES. So thus, this is the end of standard algorithms done. So if you have any queries, you can feel free to contact either through comments or through any media which you are comfortable. Thank you for listening.